All right, so today is a day 2 lesson of radical expressions and rational exponents. So today our essential question is, how do I simplify rational exponents?
And Miss Boyd was gone for day 1 because I told you, she was doing the AP test, but now she's back.
I'm back.
A rational exponent is an exponent that can be expressed as m over n, thus rational. It's a fraction. Where m and n are integers, and obviously n can never be 0 because you can never divide by 0. Radical expressions can be written by using rational exponents. So let's go through what that means. If we have, for example, here 16 to the 1/4 power, the 1 is,
It's really on the outside here.
Thank you for doing that. And the 4, the denominator, is always the index. We talked about the index in radicand last lesson. The radicand is 16, the index is 4. That's always in the bottom, the bottom of the fraction.
Okay.
Okay? All right, do you want to add anything there? Are we good?
I think we're good.
So the denominator, I just said that. Denominator of a rational exponent becomes the index of the radical. Here we go. Example number 1. So Ms. Boyd, well, we're going to write the expression negative 32 to the 3/5 in radical form.
Right.
Radical. So
Radical.
she's going to do a radical.
So I'm going to do a square root.
Underneath, the radicand is negative 32.
Right.
And now she's going to put parentheses around everything. We know the index is a 5.
Oh,
Remember?
yeah. Bottom
The denominator,
Thank you.
index is a 5, and the 3 goes on the outside. That's the exponent.
All right.
So the rule is, PEMDAS, you evaluate what's in parentheses
We
first.
got to do this first.
Right. So the 5th root of negative 32 is actually going to be negative 2. Because we know that negative 2 to the 5th power is negative 32. We talked about this yesterday. So negative 2 cubed then is just negative 8.
Great.
And we're done.
Wonderful.
All right.
That's easy enough.
Example 2. Let's just look here. Do you want to?
Either one's fine.
Let's do example 3.
All right.
Oh. Yeah, let's do this one.
Okay. So
Right.
underneath the radical is our 4. Our denominator goes here. And we put this all in parentheses to the 5th.
Yes, and one thing I want to mention is, and I don't know if I mentioned it last lesson or not, the 2. We wrote it, and I think that's great.
You don't have
but
to.
you don't have
because
to.
That's what square root means.
Right, but it's okay if we want to write it.
So we just have 2.
Yeah.
And then to the 5th, which
is 32.
32.
Do you want to do 4, or do you want to save 1 and
save
4 for
1.
class?
Yeah.
Or 2 and 4. Do you want to save both?
Oh, sure. They're quick and
All
easy.
right. So properties, lots of properties. We should go over this. The product of powers property, all that means is when you are multiplying a to the m times a to the n,
Right. So if you have the same
there we go. If you multiply the same base, you
add
add
the
the
exponents,
exponents.
just like
we
before.
know how to do that. When you divide, you subtract the exponents. When you have a power to a power, so one
Multiply.
base, and you multiply. And power of a product property, all that means is when you have 2 numbers or variables, whatever, multiplied together, you can distribute or apply the exponent
But the
to
only way
each
to
of
do
them.
that is if we have a multiply here.
Yep.
Not an addition.
Correct. Good
Okay.
job, Miss Boyd. And power of a quotient, same thing. You can apply the 1/4 in that example to the top and to the bottom.
Great.
That is the properties.
All right.
So here we go. Write each expression by using rational exponents.
So we're just
And we're
going
not
backwards.
going to simplify.
Oh,
Okay? I mean, some of these, some of them we do. Let's just see if we can
All
simplify.
right,
How about
let's
that?
check.
So we
this
start
is
with
our big
13.
number. This is our bottom
Yep.
of the fraction.
Right?
And that goes on top.
But 4 over 8 is
we
the
can
same
simplify
as,
that to 13 and 1/2.
and we leave it like that.
Okay. Oh boy, your hand got in the way.
Oh, sorry.
No, it's okay. I misjudged my box.
Right.
All right, 13 and 1/2.
Perfect.
There we go.
Let's try the next one.
All right, so 13 is our big number.
Yep.
This is our base, or our bottom, sorry,
the
not
denominator.
our base. Yep. And then 15. Well, 15 divided by 3 is, or sorry, 15 divided by 5 is 3. So yeah,
And 13
to the
cubed
third.
is, I mean, it says use rational exponents, but you can really simpliply
Yeah,
that.
you
13 to the third is 2197.
Great. That's easy.
Let's see.
Should we
I
save
think
some
we
for
should.
class?
We could save all of these for
Yeah,
class,
these are quick and
actually.
easy.
Oh,
All
here
right,
we go.
Here we go. We are multiplying, so we add
The
our
exponents.
exponents.
So the 7 stays.
So we have 7, but we have 7 ninths plus 11 ninths.
Yes.
Which is 7 and 18
18
ninths.
over 9. Notice the 9s we don't add when you're
No,
adding
common
fractions.
denominator, leave it.
Yes.
Well, this
Which
just
is
reduces to
7
2. 7
squared, which is 49. Yes.
Oh, that's easy.
Should we do?
Might as well do a division
Yeah,
one, too,
let's do a
while we're
division
here.
one. Mm-hmm.
All right, I'm just going to
Okay.
that. All right, well, our exponents this time we subtract.
Yes.
So I'm just going to kind of write over here. 3
Mhm.
fourths minus 5 fourths.
Yep, and it's 6.
Well,
oh,
our bases
I
are the
see.
same, or our denominators are the same.
Mhm.
Good. And then 3 minus 5
is a
is
negative 2, which is a negative
which
1/2.
is a negative 1/2. So we can write our base of 16
16.
and negative 1/2.
But we never leave a negative exponent, so we're going to write that as 1 over 16 to the 1/2. You're moving the
Yes.
whole thing to the denominator, and then it turns to positive.
Exponent.
But what is
Oh.
1 over 16? What is 16 and a half? What is 16 raised to the half power? That's the
4?
same as, yes. So the final answer then would be 1 over 4, because it's saying simplify.
1 over 4.
Mm-hmm.
All right. Great.
Okay. So now,
Multiply.
What do you think?
Fine. Should we do
Shoot.
a power?
should we do this one?
Well, it just,
Or-
it just goes inside, I guess.
Yeah.
That's pretty
Oh,
easy.
yeah. Should we see what we have?
Yeah. Oh, that's a quick, easy video.
Should we
I'm
just,
okay with
you want
it.
to just do these in class and
Yeah.
just be done?
Yeah.
Okay. Because the last one was kind of like 14 minutes by myself.
Oh, yeah. Let's do a quick, easy one.
So there we go. Simplify, write the expression in radical form and then simplify.
Okay.
And some easy video
Yeah,
questions.
super easy.
You guys can do this.
See you tomorrow.